Today's lesson is taking the factoring concepts that we've spent the last couple of classes working on and applying it to actually solving and finding answers for x for these equations. So we're adding basically one extra step onto the factoring process. And in order to add that step on, we need to take a look at a property called the zero product property. It says, if A times B equals 0, then either A must equal 0 or B must equal 0. Now hopefully you're looking at that thinking, well, that makes sense. If I'm multiplying two numbers together and my answer is 0, one of them has to be a 0. So let me show you how that applies to our problems that we've been working on. If you take a look here at example 1, these problems are already factored for you. This is where we would have stopped on the factoring lessons. All we're going to do is finish the problems. This is really the only new stuff this lesson. Once you get it to the parentheses, we all should know by now the parentheses mean multiplication. So we are really multiplying two things here. Well, we're simply going to let this first item be your A, and this second item be your B. So our equation really looks like A times B equals 0. So since our equation really looks like that, then we should be able to say, well, A, and A in this case is x plus 4 must equal 0, or B, which is x minus 9, must also equal 0. Now that we've taken and used the zero product property to rewrite it, now we have two very simple equations to solve. If I asked you, how do I solve for x here, you would tell me I need to move the 4 by subtracting. And those would cancel. You would be left with x equals, and 0, take away 4, is negative 4. If I asked you, how do I solve this one for x? You would tell me I need to move the 9 by adding 9. And those would cancel. And I would get x equals 0 plus 9 is 9. And those are the two answers to this equation. So truly, the only thing that is new here is once we get our two parentheses, we take the first parenthesis and set it equal to 0, and the second parenthesis and set it equal to 0. And then you solve those two equations. The only difference between A and B is it just has some extra numbers. We're going to follow the same pattern. We're going to take our A, which is 2x minus 5, set that equal to 0. And we're going to take our B, which is 3x plus 4, and set that equal to 0. How do I solve for x here? Well, the first thing I do is I got to move this 5 by adding. And that leaves me with 2x equals 0 plus 5 is 5. But I'm not done this time. I still need to get rid of the 2. I do that by dividing. I'm left with x. 5 divided by 2, in this case, is a very nice decimal, 2.5, and I will happily accept that. So look at the other equation. If I want x by itself, the first number I got to move is 4. I'm going to subtract 4 from both sides. That leaves me with 3x equals 0, take away 4 is negative 4. Divide both sides by 3. Now, if you put this one in the calculator, you're not going to get nearly as nice of a decimal. You get a repeating decimal. I will take your repeating decimal, or I will also take a fraction. So you can give me one of two answers. You can give me the negative 1.3 with the repeating bar, or if you do press math, enter, enter, the other answer I would take is the negative 4 over 3 that it gives you. That is the only new stuff today, is this zero product property. This is the easy part. If you were good at factoring, then you are good for this lesson. So now let's look at all the steps together. How do we solve a quadratic equation using factoring? The first step, and this is a new step, you cannot factor unless you make one side of the equation equal to 0. Now there's a little note that I want you to add in your notes. This is really, really important. To make your life easier, you always want x squared to stay positive. So when you're moving stuff, keep that in the back of your mind. So we've made one side of the equation equal to 0. Now we got our factoring stuff. Let's review. We have shortcuts. The first shortcut, GCF. We use a GCF when there is something in common or when there is no C term. So always look first for something in common. It makes your problems smaller and easier to work with. Dots. We're familiar with dots. We always use dots when there's no B part. There's no middle part. And then our third shortcut is easy factoring. These were the ones that we use this when there is no number in front of x squared, when it's just plain old x squared. Now we know there's going to be plenty of problems that these shortcuts don't work. So, like step number 3 says, use the British method if the shortcuts don't work. That is all the same steps that we heard a couple classes ago. The final step, which is the new stuff, we use the zero product property to solve. That's where you take your two parentheses, set them both equal to 0 like we just did. So let's take a look at some examples. Solve the following equations. Let's look at our steps again. First step, one side equal to 0. Well, this one already has a 0 right here, so we don't need to worry about the first step. Second step, we look for our shortcuts. We look to see is there something in common or no C term? Is there no B term? Or is there no number in front of x squared? So let's take a look. Do these three guys have a number in common? No. Is there a C term? Yes. Is there a B term? Yes. So it's not GCF. It's not dots. Is this easy factoring? Look at x squared here. Does x squared have a number in front of it? No. This is, and I'm going to make a little note, this is an easy problem. So if you remember, our easy problems, we are trying to find two numbers that multiply to give you negative 14 and add to give you negative 5. And we are allowed to go straight to the parentheses. So let's talk about our signs first. I have to multiply to get a negative and add to get a negative. Multiply to get a negative means I have one of each. And the bigger number in this case is negative. So a positive, a negative, this is the bigger number. Well, we don't have a lot of options. The only options we have are 1 and 14 and 2 and 7. Which pair is going to give us a negative 5 when the bigger one's negative? That will be the second pair. Positive 2, negative 7. Now the difference between the previous days and today, we have an equal 0 here. We are not done. We're going to take our first parenthesis and set it equal to 0. And we're going to take our second parenthesis and set it equal to 0. I need to solve this equation. I'm going to subtract 2. I get x equals 0, take away 2 is negative 2. This one, I need to add 7. I'm left with x equals 0 plus 7 is 7. So that's that extra step after factoring. So let's take a look at B. Is the equation equal to 0 like this one was? The answer is no. Now, let's look at our little helpful hint. Remember, you always want to keep x squared positive. Is x squared positive right now? Yes. You do not want to move him. Since we can't move him, that means that these two guys are going to have to move to the other side of the equation. Well, the way we do that is to do the opposite. The opposite of a positive 9 is a negative 9x. I'm going to do that over here. The opposite of a negative 18 is a positive 18. And I'm going to do that over here. And those all cancel. Now, when you look at our three things here, we have x squared, a negative 9x, and an 18. Are any of those like terms? No. Make sure you write them in the proper order. X squared comes first. The x part comes second. Notice I carried the negative. And the whole number part comes last. And I have my 0. Okay, so let's think through our shortcuts. Is this a GCF? There is nothing in common, so no. Is this dots? There's a B term, so no. Is this easy factoring? Is x squared by itself? Yes, it is. This is an easy factoring problem. So our goal is to find two numbers that multiply to give us 18 and add to give us negative 9. And we're going to go straight to parentheses. I need to multiply to get a positive. That means I have two positives or two negatives. And because I have to add to get a negative, that means they are both negatives. Well, 18, we have a couple of options. We, of course, have 1 and 18, both negatives. We have 2 and 9, both negatives. And we have 3 and 6, both negatives. Well, what's the pair that gives us negative 9? That will be this last pair. Negative 3 and negative 6, but we still have equals 0. So we're going to take x minus 3, the first parenthesis, and set it equal to 0. We're going to take the second parenthesis and set it equal to 0. I need to solve this equation. That would require me to add 3. 0 plus 3 is 3 for one of my answers. I have to add 6 on this one. X equals 0 plus 6 is 6 for my other answer. So we've tried two together. I would like you to pause the video and try these exact same two on your own. So let's see how you did. A already had a 0. We are ready to check our shortcuts. This is an easy shortcut. So we are looking for two numbers that multiply to give us negative 24 and add to give us 2, parentheses, x's. If I have to multiply to get a negative, I have one of each. If I have to add to get a positive, the bigger one is positive. This is your bigger number. My options for 24, negative 1 and 24, negative 2 and 12, negative 3 and 8, and negative 4 and 6. Which one of those pairs gives us a positive 2? That would be this pair right here. So we are looking at a positive 6 and a negative 4. Bring down the equal 0. First parenthesis equals 0. Second parenthesis, whoops. Second parenthesis equals 0. Minus the 6 on this one. We get x equals negative 6. Hopefully you got that answer. On this one we add 4. And you get x equals positive 4. Hopefully you got that one completely correct. Part B, you needed to get 0 first. Well, x squared's positive, leave him alone. I'm going to move this guy. I'm going to add 8 to both sides. Are any of these like terms? No. So you should have had x squared plus 6x plus 8 on your paper. What kind of shortcut is this one? Well, because x squared is by itself, this is an easy shortcut again. We're looking for two numbers that multiply to give us 8 and add to give us 6. Parentheses with x's. Positive and a positive means both are positive. 8 is either 1 and 8 or 2 and 4. In this case, it's 2 and 4 that gives us 6. First parenthesis equals 0. Second parenthesis equals 0. This one we have to subtract. We get x equals -2. This one we also have to subtract. We get x equals -4. Hopefully, those went pretty smoothly for you. So we've done several now with easy factoring. We've practiced the zero product property. We're ready to step it up a little bit. So let's take a look at some harder problems. So this first one, we're going to do together. You're going to do B on your own. Do we have a 0? No. Is x squared positive? Yes. So I need to move 15. Subtract 15 because that's the opposite. Are any of these three like terms? No. So we have 4x squared minus 17x minus 15 equals 0. Is this any of our shortcuts? Well, let's see. Is there something that we can divide these three by? No. So it's not GCF. Dots. Is there a middle part? Yep, it's not dots. Is x squared by itself? No. So this is not easy either. This is a British method problem. So let's review the British method. Ignore the 0. Start by multiplying 4 and -15, and we get -60. We are looking for two numbers that multiply to give us -60 and add to give us -17. Well, because this is a negative, we have one positive, one negative. Because this is a negative, the bigger one is negative. So we have +1, -60, +2, and -30. Divided by 3, we get -20. Divided by 4, we get -15. Divided by 5, we get -12. And divided by 6, and we get -10. There's your entire list. Which pair adds up to -17? That would be that pair right there. What do we do with those? We do not get to put them in parentheses. This is when we take this middle part and we change it out. Keep the 4x squared. Now we have plus 3x minus 20x minus 15. We'll worry about the equal 0 at the end. Split it down the middle. What can we divide these by? 1. What else is in common? X. 4 divided by 1 is 4. We have 1x left over. 3 divided by 1 is 3. We have no x's left over. What can I divide 20 and 15 both by? Well, that would be 5, but we got to remember that that negative comes down. -20 divided by -5 is +4. This x stays inside. -15 divided by -5 is a +3. Do the parentheses match? Absolutely. So now we have insides and outsides. The insides that match are 4x plus 3 The outsides are 1x minus 5. Now is when the equals 0 is important. That was the old stuff. The new stuff is setting the two parentheses equal to 0. 4x plus 3 equals 0, and 1x minus 5 equals 0. Well, in order to solve this one, I have to subtract 3 from both sides. That leaves me with 4x equals negative 3. I need to divide both sides by 4. We get x equals, if you put that in your calculator, you should get negative 0.75, and I will happily accept that answer. This one, add 5 to both sides. 1x equals 0 plus 5 is 5. Divide by 1, we get x equals 5. Okay, your turn. Pause the video. Try problem B. Okay, so let's see how you did. First question, is it equal to 0? No. You should have subtracted 23x from both sides. None of these are like terms, but make sure you watch your order. The x is in the middle. 6x squared minus 23x plus 20 equals 0. Okay? Next step, we got to figure out what kind of problem it was. Hopefully you knew that this is a British problem. So we need to start by multiplying 6 and 120. I'm sorry, 6 and 20, and we get 120. We are looking for two numbers that multiply to give us 120 and add to give us negative 23. Well, if we multiply to get a positive, you have two positives or two negatives. If we add to get a negative 23, that means they're both negatives. So let's start our list. Negative 1 and negative 120. Negative 2, negative 60. Negative 3, negative 40. Negative 4 and negative 30. Negative 5, you get negative 24. Negative 6 is negative 20. Negative 7 does not work. Negative 8 is negative 15. And negative 10 is negative 12. That's your entire list. What's the pair that gives me a negative 23 when I add them up? That would be that pair right there. So we got to insert those in the equation. 6x squared minus 8x minus 15x plus 20. Don't worry about the 0 right now. What can we divide these both by? Well, that would be a 2. What's in common? An x. 6 divided by 2 is 3 with an x left over. Negative 8 divided by 2 is negative 4 with nothing left over. What can we divide 15 and 20 both by? Well, that will be 5 with a negative. Negative 15 divided by negative 5 is positive 3. The x tags along. And 20 divided by negative 5 is negative 4. Do the parentheses match? Yes. Insides that match, 3x minus 4. Outsides that don't, 2x minus 5. Now is when the equal 0 is important again. Now we're ready to set our two parentheses. 3x minus 4 equals 0. And 2x minus 5 equals 0. We need to add 4 to both sides. We get 3x equals 0 plus 4 is 4. Divide by 3. Your calculator will give you a repeating decimal. I will either take 1.5 0.3 repeating, or 4 over 3. On this one, I have to add 5 to both sides. I am left with 2x equals 0 plus 5 is 5. Divide by 2. X equals 5 divided by 2 is 2.5. And hopefully you got that one right. So we practiced some easy. We practiced some British. So let's look at some of our other kinds of problems you might see. Lots of numbers on these. Let's take a look at the first one together. Do we have a 0? No, we don't. We need to move this guy by adding 48. Now, which one of these three is a like term with him? He's a whole number. 60 is a whole number. There's your like term. The 3x squared stays. The plus 36 stays. 60 plus 48 is a positive 108. And we have our 0. Let's start with our shortcuts. Is there something that all three of these have in common? Yes. They are all divisible by 3. So I'm going to pull a 3 out and one big set of parentheses and see what's left over. Well, 3 divided by 3 leaves me with x squared. 36 divided by 3 leaves me with positive 12x. 108 divided by 3 leaves me with positive 36. Worry about the 0 at the end. Now, we're going to ignore the 3, pretend it's not there. Look at what's left in the parentheses. And you know what? Let's do this to make it go away. Let's just highlight that 3 so we pretend he's not there. Now, if you look at what we have left, let's go through the rest of our shortcuts. Is this a dots problem? No, because it's got this part here. Is it an easy problem? Yes. X squared is by itself. This is now an easy problem. First it was a GCF, then it turned into an easy problem. So now I'm looking for two numbers that multiply to give me 36 and add to give me 12. Now I get parentheses right away. X's, positive multiplying, positive adding, means two positives. What are my two numbers that multiply to give me 36 and add to give me 12? Well, it's either 1 and 36, 2 and 18, 3 and 12, 4 and 9, or hopefully the one that you guys knew up front, 6 and 6. Now, we need to bring down the equal 0. We also need to bring down the 3. Here is the important part. If your GCF is just a number, there's no letters there, then we can truly just pretend it's not there. If there was a number there, or a letter there, which we will get to, we'll talk about it. So he was not important. So now it's just x plus 6 equals 0 and x plus 6 equals 0. Hopefully you're thinking already, well, these are going to be the same answers, because you're right. So I'm going to subtract 6 from both sides, and I get 0, take away 6 is negative 6, and the same thing over here. I get asked, can I write it one time? Sure. Can I write it 2 times? Sure. Doesn't matter as long as you realize that they're both the same answers. Okay, pause the video. Try B on your own. Okay, so let's see how you did. First thing, do we have a 0? No. I'm going to do the opposite here and add 10x. Where's my x? That's my middle part. I'm going to add 10x there. Negative 2x squared. 14 plus 10 is 24x. Bring down the minus 70. And we have our 0. What kind of shortcut is this one. Hopefully you are saying right away that this is a GCF problem, because you are correct. What can we divide all three of these by? 2, but we're going to be even more helpful to ourselves. We're going to divide by -2. Don't worry about 0. -2 divided by -2 leaves me with x squared. 24 divided by -2 leaves me with -12x. And -70 divided by -2 leaves me with a positive 35. So now, ignore that guy. What kind of problem do we have left at this point? Hopefully you said that this was now an easy problem, because you are correct. We need two numbers that multiply to give us 35 and add to give us -12. We got x's, parentheses. Since this is a positive, we either need two positives or two negatives. Since this is a negative, two negatives. 35 only has a couple of options. 1 and 35 or 5 and 7. Which pair gives you a -12? That would be 5 and 7. Bring down the equal 0. Bring down the -2. Does the GCF have an x with it? No. Not important. X minus 5 equals 0. And x minus 7 equals 0. Here we have to add 5. So we get x equals 0 plus 5 is 5. Here we have to add 7. We get x equals 0 plus 7 is 7. Okay, we have one final pair of examples to look at. These are more of your kind of specialty cases. Let's look at A. What do you notice is missing? Hopefully you're saying right away, there is no B part. And when there is no B part, these are dots problems. However, dots problems need perfect squares. Can you square root 11? No. Can you square root 44? No. So, before we do dots, we got to find another shortcut. Is there something I can divide both of these by? Yes. This is a GCF problem first. We can divide 11 and 44 both by 11. 11 divided by 11 leaves me with x squared. 44 divided by 11 leaves me with -4. Now, if I cover up the 11, what kind of problem do I have now? This is now a dots problem. Dots problems, we need square roots. Well, what's the square root of 4? Hopefully everybody knows that is a 2. So if you remember from dots, we go straight to parentheses. We have x's. The trick with dots problems was there was always one positive, one negative. Always. The 2 goes in those two slots. Bring down the 11. Bring down the equal 0. Now, let's take a look at the next step. Does our GCF have an x with it? No. Cross it off. X plus 2 equals 0. X minus 2 equals 0. Here, subtract 2 from both sides. We get x equals 0. Take away 2 is -2. Here, add 2 to both sides. We get x equals 0 plus 2 is 2. Let's take a look at B. Does this one equal 0? No. I want x squared to stay positive. I'm going to move him. The opposite is adding 10x. Are these like terms? No. One is x squared, one is a regular x. So we have 45x squared plus 10x equals 0. Let's go through our shortcuts. Is there a GCF? Yes. And there's a GCF for two reasons. There is something in common, but there is also no C part. If there is no whole number at the end, it is always a GCF. So first question, what can I divide these both by? Well, that's a 5. Is there anything else in common? Yes, there is an x. Let's see what we have left over. 45 divided by 5 is 9. 2, take away 1, leaves me with 1. 10 divided by 5 is positive 2. 1x, take away 1x, leaves me with none. Does this one look a little different? The answer is yes. Okay, here's a little special note I want you to throw out there. What's the one thing you don't see anymore here? X squared. So make yourself a little note. When x squared is gone, you are done factoring. However, we are not done with the equal 0. Okay, it's a slightly different question. Does my GCF have an x with it? And the answer is yes. If it does, this is technically your first parenthesis. We're going to say 5x equals 0 and 9x plus 2 equals 0. So anytime your GCF has an x, it's your A. Now, I need to solve this. The only thing I need to get rid of is the 5. I'm going to divide by 5. I get x equals 0 divided by anything is 0. Over here, subtract 2 from both sides. We are left with 9x equals negative 2. Divide by 9. Your calculator should give you a repeating decimal here. Negative 2 divided by 9 is negative 0.2 repeating, or if you hit math, enter, enter, it's also negative 2 over 9. And that is the end of the lesson, and I will see you next class.